move your desk so you can get your the view of the screen or whatever. I'm going to start recording some of the things that we do in class and then post them on my website. Okay, so if you missed something in class, or if you need to, and you're taking notes and your notes weren't all that clear to you, you get the instructional part, you can go back and watch the video and brushing up on things a little better. See how that helps us with grades and stuff like that. If it becomes something that is beneficial, we'll keep doing it. If not, probably do it for a week or so and then reevaluate and see if it's worth it or not. But number 9, find the equation of the circle shown in the figure. When you find the equation of a circle, there are 2 things you need. One being the center. Okay, so here we see the center is located at -2, 2. Bless you. Okay, so let's see. Right, -2, 2. So remember it's x minus h squared plus y minus k squared is equal to the radius squared. H and k being the ordered pair, alphabetical. Okay. So now we're going to go x minus -2, so it becomes x plus 2. And then y minus 2. And now we've got to find r. Okay, so r is the distance of the radius, right? So you need to use 2 points that you know for certain exist on this circle. Alright? So my suggestion to you is to go around here and try to find some spots that you know that circle passes through kind of the intersection of grid lines. Okay, so you know exactly what we're looking for. So we're looking for maybe like that point right there. You see how that point is the intersection of the grid line at y equals 4 and the grid line of x equals 1. Okay, you want the exact intersection because we want to use that exact point. Okay, we would hate to use like this point here because then we're kind of approximating is that maybe -1.5. Sorry, -1.75, and then up here maybe it's 5.7 or something like that. Does that kind of make sense? We don't want to have to estimate that way. Now, if we did estimate that way, we'd get something close to what we're looking for. But remember that the computer is looking in this case for that 13. And if you get 12.8, okay, pretty close, right? It's still going to mark it wrong. All right. So you want to find either that point there. There's another one over here. One down here. There's one here that's pretty useful. Okay. As I look at this, thinking of the ones that are useful, okay, there's one there, and there's one there. Okay, I know I got to use -2, 2. All right, but of those 5 points, okay, I think it makes sense to use either that one or that one. Why would it make sense to use those?
Because they have zeros in them.
Okay, because they have the zeros in them. Okay, so now what we have to recognize is how this axis is orientated, and we're seeing that so it's 4 markings, 4 tick marks between 0 and 2, so it's counting by halves, right? Okay, so this point here is the one I'm going to use. It would be 0, -1. All right, so now finding the distance, if you remember that's subtract your x's. So my radius is going to be 0 minus -2, so that's 2. We'll square that and get 4. So you take the x's, subtract them, square them. Okay. Add to that the same thing with your y. So we're going to 2 minus -1. 2 minus -1 is 3, right? 3 squared is 9. So we get r is equal to radical 13, correct? And you would have found the same thing if you would use that point there, that point there, or that point there. Just this subtraction and then squaring process is a little bit easier if we use a coordinate that is a 0. So what is then going to go right here? 13. Just be cautious. I see a lot of people when they ask me questions, they've got everything up here, but they've got a radical 13 here because they forget that that's r squared and not just r in the formula. I'm also seeing a lot of people going through and they come up and ask me questions and we go through this, and they're telling me everything that they need to be doing, so that they're just kind of confirming that they're doing the right process, and then they get back to their desk or go home or whatever, and they type it in, and everything that they've done is wrong, or it's saying that's wrong. And the reason is they're not paying attention to the variables, okay? I saw several people yesterday have x plus 2 squared plus x minus 2 squared, and that obviously counts it wrong because you don't have the two variables. I saw y plus 2 and plus y minus 2, okay? So you have to use x and y. Does that make sense? All right. So that was 9. Go to, somebody wanted to see 10. 10 says show that the equation represents a circle by rewriting it in standard form. If you've been working with anybody, if you see the red numbers throughout the entire year, the red numbers indicate that those are the values that change from person to person. Okay? Which is nice for you to see because maybe you could be working with somebody and now you know how yours, a little bit quicker maybe, differs from theirs. But remember, we wanted to talk about taking the x's, using the commutative property and rewriting them next to one another. We're then going to leave a blank spot, and then we're going to take the y's, and we're going to do the same thing with the y's. So we go y squared plus 6y plus, leave a spot. And these are always going to be plus signs here between the blanks, okay, because we're going to take a number and square it, and that number should always become positive then. But then we've got to move the 14, move the constant to the other side. Because we're going to complete the square on the red expression and then on the blue expression. So completing the square here, take half that number and then square it. So 3 squared is 9, so add 9 here. Come over here, add 9. Got to keep that equation balanced. Do the same thing here. Okay, so in this case it just ends up being the same 9, but a lot of times those are different. So now this becomes, if you remember from what we call this a perfect trinomial. And we can now rewrite that. Why it's called a perfect trinomial is because you can even rewrite it as a binomial squared. So this term here is always the square root of that term. And then it's always whatever this sign is, so it's a minus sign now. And then that b over 2 term, the term that you had when you took half of the middle. Okay? So for us it was 3, right? So minus 3. And we'll square that. Come over here to the right hand side, or the blue side, I guess. The blue portion. Square root of the first term. Okay? And now plus sign, so we'll put a plus sign. And then that b over 2, which was 3 again. And then we'll square it. What I usually do, just to make sure I've done that right, just quick, you guys know how to do this quickly. FOIL this back out. X times x give me x squared. Negative 3x, when I multiply those together, double them gives me negative 6x. And then negative 3 squared is positive 9. So I know that this term here, this binomial squared is the exact same thing as that trinomial. And then I can do the same thing there, and they will match up. So then I get, what, 4 over here, negative 14 plus 18, so I get 4. So when they ask us what the center is, okay, remember it's h and k, and this is always x minus h, and this is always y minus k. So basically what we do is we take the opposite of that number. Okay, so h is going to be positive 3, and k is going to be negative 3. Okay, and hopefully you realize that from that kind of activity of where we move the circle left and right. The x minus 3, remember that moves your circle to the right, correct, from 0, 0. So it's got to be a positive distance on your x-axis for the center. And then the radius, remember, square root that number. Okay, that's usually, I usually don't see too many people struggling with, like this type of question, struggling with those two. It's this one that they keep putting 4 in for. All right. For some reason, it's always a big issue with that r squared that throws a lot of people off. Okay. 11. I know somebody wanted to see 11. Actually, I'm going to skip it just to save some time, but it's the exact same procedure. Okay, it's the exact same question. You're just now dealing with. You're going to take the x, take half of that, you'll get 4, so you'll add 4 to the left-hand side, add 4 to the right-hand side, and then 14 y, so say you'll add 49 to the left and 49 to the right. Should be able to write as a binomial x minus 2 and a binomial y plus 7. And then the right hand side becomes 16. Was there anything in regards to like the symmetry that we wanted to talk about, any of these questions? You guys felt comfortable doing that stuff? Alright. Second. Your question? Or? No, you're good. Okay. Remember, that's just plugging stuff in. Okay. Just kind of rehash real quick. If I want to do x-axis symmetry, okay, that said, if you have the point x comma y, what's the other point that should exist to get x-axis symmetry?
X comma negative y.
X comma negative y. Good. Okay. And basically all that means that if I want to see if this thing has symmetry with respect to the x-axis, all I've got to do is where I see an x, I plug in this point. Okay, so I'm going to plug in this information here into this equation. So wherever I see an x, I plug in x. And wherever I see a y, I'm going to plug in negative y. And I'm going to go through the entire problem. However many times I have to do that, I'm going to evaluate and simplify that expression. So let's just do an example here. So if I got x becomes x, that's pretty straightforward. But this y becomes negative y. And you just got to make sure that when you substitute, you're substituting the entire object negative y. Okay, because that becomes now negative y times negative y. If we didn't put parentheses around that, we're not fully substituting kind of a one-to-one idea there. So then plus, okay, x stays x because that's what this point is saying to me. And then this y becomes negative y, and we're going to see if that equals 9. So if I go through and I start evaluating this, well, negative y squared, not evaluate, I keep saying the wrong word, simplifying this. Negative y squared is just y squared, so we get x squared, y squared. But over here, this becomes negative xy equals 9, right? So you simplify things, and when you're fully simplified, you get all the way down to that, you take that and you compare it to what you started with, okay? If they are the same, then your answer to the question is yes, we have symmetry about whatever axes or the origin. But if they're different, you don't have that symmetry, okay? So we see here, obviously, it's got the solution highlighted. The graph has symmetry with respect to the origin. So let's just go and see what that would look like for us. Once, since we know that's going to happen, maybe we can do the algebra and see the outcome. Okay, knowing that it's kind of a trivial thing since we already know the answer. So if it's symmetric with respect to the origin, it's opposite x, opposite y, right? Okay, if xy is on my graph, and so is this point. So we're going to start plugging things in. So everywhere I see an x, it's now negative x. Everywhere I saw a y in my original thing, it's now negative y. Plus then x again is negative x, y is negative y, equal to 9. So I square this one, square negative x gives you x squared, square negative y gives you y squared. Okay, now over here, a negative times a negative is just a positive, right? So xy again, and I get 9. So that's the simplified version after we substitute. Is that identical to what we started with? Yeah. Okay. Now, the reason they give you questions like this is because they know, as an author of this question, you guys have TI 83s and 84s at your disposal. Okay. WebAssign is kind of designed for you to use it in conjunction with that calculator. Okay. There will even be things in these assignments that say, using your TI 83 or 84, do this. Okay. So they know you've got your calculator. And they know that you can probably look at things and from that calculator, graph it and say, oh, this is symmetric about the x-axis or the y-axis, and get that answer real quick, right? So that's why they're giving you pretty nasty looking functions here, because can I type that into my calculator? No, because my calculator is predefined to be y equals, and everything over here has to have an x in it. So you can't rewrite that very conveniently to graph. Now, if you're using the GeoGebra stuff, that would obviously be something that you can do pretty quickly. Okay, so you're going to see some stuff where they create expressions or equations, knowing that it's going to be very hard for you to use technology to get a quick answer, and they want you to go through the process, and that's what I want you to do as well, is learn the ins and outs, and then we'll come back later and say, okay, now that we know how to do that, let's now use our calculators to circumvent the work, because we already know how to do it. All right. Is there anything else on there, you guys? I mean, I know that was basically my question, but we feel comfortable with everything so far? Circles, symmetry, Let's talk. Let me do this real quick.